Imagine after the class I will send the project. So.
Okay.
Yes. Or I can send even as we are speaking. Or let me send it after the class, the project 1. So. Let me open my art studio. Nani mwingine ako na swali? Any other with question? Any other student? Mr. John, you can now differentiate what is a vector and a matrix as far as this language is concerned. Sit down.
Yes.
Very good. You can store some data in a vector form and do ABCD. For example, you can multiply a vector by a vector. Sit down. You can produce or you can write a command that will produce what? A matrix. Sit down. So I expect to do some things on that area. I think we can start now. If you encounter, okay, my advice to you, you can't understand this language on your first encounter. So for example, what we did yesterday here on class, you can't understand them if you don't do revision. So you just go back, do some revision here and there using the same notes. That's when you will understand this language more. So yes. So what are we supposed to cover today? Have you loaded the packages, the data? Not data actually. I think you have loaded the commands. Today is on day 4. So this is day 4. Let me check it. Open the commands from day 4. So open this command here. Online day 4. Open online day 4 commands. Yesterday we did let me share my screen with you as we continue. I think you have the notes, you have the commands, the R script command. Let me open my machine. Is my screen visible from your point? I want to hear from you.
Not yet. Display screen.
Okay. Let me do it here. Is it visible now? I want to hear from you.
Yes.
Okay. Let me open the commands for D4. Yes, that is it. You remember yesterday, our main topics that we did yesterday was this one here. Let me open them. Yes, these ones here. We did vectors. We did subsetting of entries. We did matrices, character vectors, and a list where you can choose you can create a list of things that you want to do, and you can delete some lists. All you can rename the list entries also. The list entry. Now, yes, today what we will be covering, we will continue with the character vectors. This one here, and from there I will show you what we are supposed to do. In our course outline, you will notice that after today's class is the time when you will have what? Your project for this week. So you will have to go through the notes for the from day 2, day 3, and what we will be covering today. And what we will be covering today. This is just I can call it a revision of what we did yesterday. And then from that we will do ABCD. I think we did up to this point here. Okay, let's start from here. Today is just a continuation of what we did yesterday. Today we will do some data types, for example, of which I know we have done some. We will be doing matrices, and we will do some vectors and the data structures For example, you remember yesterday we talked of character vectors. And we said the character vector is just an atomic whose type is character. You can see what we have inside here are character values. But now when we implement or when we create a vector called, for example, x in our matter, what we have in that vector is character values. That is what we call a character vector. A character vector. Then we type the type of x, the data type. Type of is a command in type of is just a command in R for returning the type of data in that particular vector. For example, when I execute this command here, I have saved my data. I can print type of X. Yes, the type of X is a character value. So when you print X, what do? You print all the values that are inside that particular X, inside that particular X. So that's what we did yesterday. Another recap on the same is this one. So today what we will be covering, we will cover what we did yesterday and the day before yesterday. Then from there I give you a project. So is it okay before we continue? Is it okay before we continue? Okay, let's continue now. If you have any question, please ask. So what is the type of X in this part here? I want one of you to tell us the type of X before I execute the command. What is the type of the data type of X? I want to pick one of you randomly. Mr. Patrick, what is the data type of vector X? Patrick Sami? Patrick, I want one of you to run this command and tell us the type of data this vector carries here.
Okay, the type of X is character.
Why? Yes, this is character. Sawa. It's true, it's character. And I can see what we have here. We have values that are quoted, and we have others that are not inside this marks. So they're not applicable. Why is not applicable a character? Nataka kuona kama mnaelewa from the day we started.
I want to ask a question. Is it a logical function?
Pardon?
Is it because it's logical? Logical, yeah.
Are you sure?
No.
Logical operators are the true, false, sindio?
Yes.
What about null? Nataka tuulizane maswali hivi ili mpate, sindio? Ama what are you thinking? Sababu najua you will have to think and rethink in your project. So today I want us we do a lot of discussion here. Is it making sense? Is it making sense? Yes. So why is na a character? Why is na a character? The not applicable sign. I want to hear from you. I want to pick one of you randomly. Beatrice. Beatrice. Scholar. Okay. Now remember this sign here represents the missing what? The missing value. represents a missing value. So it means our programming language assumes you will insert a particular value inside it. So if it's a box or is an array, for example, with a missing value, that is actually a character. That is a character. They're not applicable in it. Can be null, the null NUL, for example, and the other sense that I used to return this particular words. The particular not
Question.
applicable. Yes.
So NA can be used to represent a missing string, right?
What?
It can be used to represent maybe a missing string type character. Yes?
Not necessarily a string, but any.
Yes.
But any it
Okay,
can.
that was the question.
Yes. Yeah. So when you return this type of
question.
yes.
So why did you declare that the type of X is character?
The type of
yet you have said that the NA can take any of the missing values, including like the logical.
Okay. Now that is the programming part of R. So that's just I can call it a directive. For example, I will answer you for. I will tell you this. Are you getting me? Are we together? Are we together?
No. Please repeat. You broke.
Now I'm on the procedure. Am I audible? I can see.
Yes.
Yes. Now, remember, I will answer you that. I will answer your question in this manner. What else can you use to present a missing data, for example, an integer, apart from null? Now, for example, if I want to return a missing value of integer and I want to assign some specific values, I must declare them inside my programming part. So for example, you have numbers from 1 to 10 and you have 7 is missing. When you insert null, not the NA, when you insert that particular value, you are telling the compiler that this missing value can take any what? Can take any data type, any type of data. But now, the basic understanding of the compiler, or the way the compiler has been programmed in this case, it will understand it now as a string, as a character. As a character. Is it making sense? Am I making sense?
Yeah, na kuna swali lingine.
Yes.
Sasa, what's the difference between na and null?
What is the difference between
Na, you missing value, and null?
Difference between the na, yeah, for not applicable, and null, and
Yeah,
null
na,
for n, just spell
the difference between NA
Uh-huh.
and NU double L.
And NU double L
Yeah.
in R programming language. So.
Yes.
Uh, I will. What type of example can I use? I think let me use a simple example here. Uh, when we have missing values, for example, the strings. So the strings. So I'm talking as far as the R programming is concerned. So we have two values, the na and the null. So in statistical data sets, we often encounter some missing values. See there, when we encounter these missing values, we will use what? We will use either null and or null. So which we present in R with the values of null. So null. Na NA. The null, on the other hand, will represent the value in questions that does not exist. So that does not exist. For example, when you have a sentence, and you have some missing values in that particular sentence, the value we use is not in null of NA but the null. Is it making sense? But in our programming language, you will notice that what we use most is the null. So
So what I'm getting is
uh-huh.
that null is for unidentified,
Uh-huh. Yes.
A is for missing.
Yes.
Okay.
So yes. Any other question before we proceed? So if you don't have any
Excuse me, null is for what?
Pardon?
Null is for what and what?
Well,
Why? Maybe Peter, amesema sijui null. Sijui identified, sijui then what? Like,
null.
mm,
Null for, yeah, we have the two nulls, So there,
yes.
we have one for NA and the other
And
for
then, yeah, the last point that you guys have said, I don't know, null is for what?
null is for the unidentified. For example, an non-existent or empty value or a set of values. So
Yes.
is it making sense?
Yes, and then NA?
NA is for missing values.
Okay.
So in this programming language, you will notice that we don't apply the null so much, but it's also applicable. The language supports the two nulls, but we always use null for most of operations that we do in this language. From that, we have the subsettings. So we use the subsetting to allow us to access elements from objects. When we have 10 entries in data, you can subset the first 5, or you can subset the first one, or you can subset all of them. And remember, we used what? We used the closed bracket. So it will so what does subsetting do? It takes out a position from the object based on the conditions provided by the programmer. Based on the conditions provided by the programmer. And there are 4 ways of subsetting. Remember, we used this one here to subset, for example, and we did an example here. where x can be. Okay, I have a question here. Today we are answering questions, asking questions. Before I continue, when I say x is equal to 1 up to 15, 1 to 15, is this x a vector or a number?
Vector.
Why?
Why? Siko na values from 1 to 50.
Unajua, actually that is the reason why we call it a vector. Na kuna mwenye ajui what do we mean by vector, si ndio? Kuna mwenye anafikiria in vector we must have the C function for storing data, si ndio? So venye umeelewa hivyo, you are good to go. So kuna mwenye hapo amepata. That's why when we execute this command here and run the command there, you will get the values from 1 to 50. So this is a vector. So what is the use of cat function? Nataka mwenye hajashika anything aelewe. What is the use of cat function in R? I sent it yesterday and the day before yesterday. Mary Dama, what is the use of cat? What is the use of cat? Any one of you to tell us. What is the use of cat? Mr. Benson, what is the use? Yes?
I think
Uh-huh.
for displaying.
For
I
displaying.
think it's used to display data. Okay, let's say a string.
Very good, very good.
Yeah.
And what you are displaying must be in quotations. Slow.
Yeah.
Yeah, very good. Very good. So you will display something somewhere in your project. So.
Okay.
Okay. So begin on that. And so for example here, that these are the values of x from 1 up to 15. Then we can display the values of. Now when you say cat origin of vector, the cat function or the cat command will display the values in what? The values that are inside these braces here. So the values that are inside the braces. And instead of displaying the value x, we display what? The values that are stored in that particular x. So now subsetting, now you can pick values, for example here, values of x from 1, for example, up to 5, or 1 up to 3. So you can subset the first 5 elements of vectors. This is the message that will be displayed here now. And instead of having 1 up to 15, we display what? 1 up to 5. That is the use of what? The use of closed bracket here. That will be the use of closed bracket. So when we execute this command here, what happens? We have the values from 1 up to 5. We have the values from 1 up to 5. Now when I display the first 2, for example, I will just get the 2 values. I want you to tell me what will happen, or the use of minus C here. I want to see when you wanakumbuka what you said yesterday about the negative here. What will this negative do in this vector? I want to hear from you. This negative here, the negative on command on number 33, on column number 33, what will it do?
I know I think it's about arrangement, but I can't remember. It reverses the arrangement.
No. Another one. So nataka tulizane
It's the
maswali.
same.
Yes.
Like that negative c
Uh-huh.
inamaanisha we want to return everything in x except those values inside that concatenation function.
Very good. Very good. That is the answer that I wanted. We said negative will display values of x apart from the ones listed here. Apart from the ones that have been listed inside here. So when we execute this command, what happens? We when we execute this command here, what will happen is the values of x apart from the ones that are inside. So I remember I added this one here. I remember I added 5 here. So even here we can add 5. So we can add 5 and we call it Mishwa story. So without values present at x, values 1, 2, 3 and 5, we have these are the values. So and you can list what happens when you list
I have
all
a
of them.
question.
Yes.
Now, if we go to the first example, where x is equals to 1, of course 15, that is the vector itself, yeah.
Yes.
Then we go to first 5 values of vector x, the brackets, square brackets 1 is to 5. When you run that, you get 1 to 5, yeah. Now I've just removed the negative here from what you are doing, and I get 1, 2, 3, 4, and 5. So does it mean that if I put 1 colon 5, I'll get 1 to 5 with the same?
On that you are talking of command line number that is
the last example.
the first
5.
example.
Now I'm trying to relate the first one to the first example to the second example.
Yes.
Removing negative on the C, and then removing 1 to 5 and just putting a colon in between.
You can share with us your screen so that you can demonstrate to us. No?
Let's see. Just a minute.
Yes. Let me stop presenting. So share with us your screen.
Can you see my screen?
Yes.
So look at where my cursor is, yeah?
You can zoom out.
Zoom out?
Yes.
How do I do that?
Una zoom tu ukitumia your 2 fingers while your cursor is there.
This is what I want us to look at, actually.
Yes, you can just zoom out. Try to zoom out.
Fortunately, I don't have my mouse here, so I
Okay, I can see.
do that.
We can see. Just the percent.
So it's just I've not run it because I didn't want to run it and then I get it. But this is what I was talking about. X, the bracket, the square bracket, then C, just remove the negative, then 1 colon 5. Let me see what you get. I don't think it's going to run.
What are you getting?
Saying create hash. It's just giving a create. It's not giving a result. Yeah. I don't know why. So yeah, it is getting the same thing.
It's getting the same, huh?
Yes, the same thing as the first one. Yes.
So what is present in
So
our...
my question is now, why the C then?
Why?
Why, why? Because if you put X and then
Okay, yeah,
square
yeah, yeah.
bracket C,
Okay, actually, I've understood
why
your
the C
question.
then?
Well, I have understood your question, huh? So, without
Yes.
without values, without... I want you to read the message that will cut, that will be displayed after cut. So without values present, so without values what? Present.
Yes.
But
Present.
what is the output after your message hapo chini? So without values present at index 1, 3 and 3, for example
3,
here, what is displaying?
1, 2, 3, 4, 5.
1, 2, 3, 4, 5. Sawa.
5.
So it
Yes.
means you have done nothing. You have displayed only numbers from 1 to 5. Sawa.
Yes. Now my question.
Yes.
Get my question kindly.
Yes.
The first one is X square bracket 1 is to 1 colon 5, right? Then
Yes.
we close by square brackets. Yes.
Yes.
The second case, it's X. Just ignore without values. Ignore that statement. Yeah.
Yes.
I want to understand why X square bracket 1 colon 5 colon, and then you close. And the second statement, X square bracket C open bracket 1 colon 5 close bracket, then square bracket again, are the same. Why the extra C and then you with the bracket inside?
Why extra C with the bracket inside? So,
Yeah.
okay.
So I wanted to understand why the C was there. That's the first thing. Why couldn't we just do away with C? Let me see.
Yeah, nimekupata.
Nimekupata.
Hata ukitoa C you will get the same answer. Si ndio?
Yes.
Hata ukitoa C you will get the same answer. And
Yes.
I think these are some basics of programming. So we introduced C for the negative part, but we haven't introduced C here at first for displaying values from 1 to 5. I think that's the same. Yeah.
Sasa tunaweza saidiana kujibu. Like unaona kwa Benson.
Yes.
Move your cursor to the next line.
Next line.
Yeah.
It's method. That's method 2, I think.
See hapo, like rudi tu hapo juu hapo kwa blank space.
Okay.
Yeah.
Okay.
Hapa chini after yani line 37, hebu enda line 37. Yeah, hapo tuseme we want to create a vector named A having values 1 to 5, si ndio?
Very good. That's the same idea I wanted to present. So you can present Mr. Kabila.
Sasa andika
Should
A
you
is
share your
equal
screen, Ama? Okay,
hata hiyo hivyo 1 to 5. 1 to 5. Yeah, alafu next line andika B assign B hata hiyo V assign to
hear you. Okay.
assign that B to C. Andika the same thing in bracket 1 to 5 vile ulikuwa umesema tu. So unaona in the first one ni A is 1 to 5, si ndio?
Yes.
Na jana tulikuwa tumefanya sequence. Tunataka values from 1 to 5. So when creating a vector, kama uko na hiyo column like 1 to 5, like unataka range from 1 to 5, kuweka C is optional. but kama si hivyo like unataka 1 3 5 like unataka tu create normal vectors lazima uweke c. Kama uko na
Okay, I
range
get
1
you, I
to
get you. Okay, nimekuelewa.
sawa.
Nimekuelewa. Random values. If you have to do random values, then the C would be necessary.
Yes.
Thanks. That was the confusion. I think the example you used was what was confusing. Thanks.
Okay, welcome. I think if you have any other question, you can just ask. So we are here to help each other. So I may understand in a concept that one of you may not understand, but you have understood better. Well and good. You can help us learn more and more. Now we can continue. Ladies kwa nyumba, you are very quiet. I don't know why. So here is we are on subsetting. The second method of subsetting data. The second method of subsetting is by what? Is by using this double closed brackets. They are used to this sense here. They are used for subsetting of list objects. So they are used for subsetting list objects. So the operator is the same as this one, the single closed brackets, but the only difference is that these double brackets will select only one element. Whereas this single operator can select more than one element in a single command. Are we together? Okay. Let's demonstrate this type of command now using this example. We can create. Remember the syntax for creating a list. A list count is. Then it's a list of A1, B2, C10, and D20. So this is our list. So we can display our list. This is our list here down, and you can select the first element or the second element or the third element. From this particular point. And our first element, for example, what happens when you insert 1 here? When you insert 1, our first element is 1, our second is 2, 10, and 20. So our first element from this list is 1. Is it making sense? Now, this double closed brackets will be choosing or will be selecting the vector entries that are displayed on this output. On this particular output. So this is the first one. This will be the second one. This will be the third one. But now, one may ask, okay, this is a question. So you prepare to answer. Why do we have ones here? We have 1 here. We have 1 here. We have 1 here. We have 1 down ones here. Why do we have those ones? Before we continue. Why do we have ones? Mr. Benson, why do you think we have ones here? These ones in closed brackets.
Because of the number of rows.
Yes.
I would assume all of them were supposed to be on the same row, that on a different row, because that is from the list A is equals to 1, B is equals to 2, C is equals to 10, D is equals to 10. So those are different.
Very good student and good student. Aki mnataka kasonda. You are understanding the language. But girls, the ladies, not girls are for high school. Actually, that's the correct answer for that question. You remember I told you earlier that all these entries are in the same row. So they're in the same row, but they are in different words. For example, different columns, or in different positions. So I want position 1. This will be taking position 1, position 2, position 3, and position number 4. So yes. So you can select the third one, for example, the third one, and try to display and see what you are getting is 10. So is 10. Do you have any question there before we continue?
Yes.
Yes.
Though si hiyo kitu umefanya hapo.
Uh-huh.
This hebu songa hapo kwa line 51 towards the end of the code.
Uh-huh.
Yeah, hiyo last thing umeandika hapo ni nini? Hiyo stroke ln.
See, by the way, CL ni kama yenye ya kundi gani sasa yenye inaangalia the other side, si ndio?
Kazi yake ni
Kazi yake inakuanga ya any command that will be following will be displayed on the following line. Sawa. Hii ni kama kuambia this command that everything will be displayed on one line apart from any other command that may be carrying content of this line here to be displayed on another line entry down here. Sawa. Yes.
yes
Umepata?
yes nimepata na sasa must we have it there?
What do you think? unajua kwa language we have some syntax works with some conditions, and whereas you may encounter some problems while you are performing the same operation using different words, different command entries. So for example, let's try to delete it. I think it will work out for this matter because we don't have any other command downward here. Let's see. Yes, we have it here. It's working out. But remember, we don't have any other command here. Any other command that is following here. So hatuna any other command yenye ina follow hapa yenye ingekuwa inataka kudisplay on the same words, on the same line. So are we together?
Yes.
But utaenda upate there are some command hapa yenye inataka the same content hapa, yenye inataka kuperform the same programming part hapa, so tunataka display on the following row. So lazima uweke hiyo the ln hiyo inakaa kama ln. So yes, we can perform the second one here. We end a list of we have a list here. How many entries do we have here? I want to see. We have a list, for example, inside a list here. See there. So we have Z is a list of A, where A is a list of X, 1, Y, G, F, G. Then we have the B values from 1 to 10, for example. When we expand that point, we can come up with the original list here. You can see what we have here after this comma here. So after this comma, we have the values of B, which are these ones here. We have the B's. We have the values of I want you to begin here. When you are displaying a list inside another list, we use the compiler would use the sign dollar, for example. You remember very well when we were displaying in SQL, we want to display customer forms. So now we would say select star from store dot customers, for example. When we were typing the word store, then you click on the full stop, that's dot. All the columns in that particular table were coming out. So now, those in our programming language we use the dollar sign yenye iko kwa number 4, this dollar sign here, this dollar sign here. So when you look on this entry here we have y, but it's from a, so and we have x from a, so that's why we have an independent value of b here. Here we have independent value of a, but we have a subset of y. That is why we have two what? We have two dollar signs there. That's how we differentiate a list inside another list. So for the a, what do we have? We have the x for a, we have y for a. So that is it. That is how we display those particular entries. Now let's try to print the value of z, for example. So remember this is our list called z. So this is our list called what? Called z. And remember, the double closed brackets will display values on our first and second entry according to our command here. Using the C function. So using the C function. For example, now you can actually return the values on first and second entry without using the C function. But let's try to use the C function here and see what we will get. We can pop out that point here, then we print the values. So now, what is the value of our first row in second entry? First row in second entry of our list. You come here. This is your first entry. This is your first entry. This is your second. This is your that. So that is your that. So when you return the second one, you get that point there. What happens when you return the third one? Error isn't subscript out of bound. Why? Let's see. Why are we getting subscript out of bound out of 1? Okay, this is the reason. When we return some entries, well, remember here we have tried to return values from 1 up to 10. So these values are taking more than 1 byte of storage in the R programming language. For example, 1 is taking a specific entry, 2 is taking a specific entry, 3 up to 10. Now, when you call a specific number, then that number will come out. So that's why here we have one number, here we have a string. In B, for example, if we end let's say 5. So let's say 5, for example. and try to execute this command here. Let's see. Why do you think we are getting the script out of bound? I want to hear from you. What are you thinking? What are you thinking, guys?
Hebu rudia swali.
Why are we getting a script that is out of bound? Are you sure this will work? I think it might. Why are we getting it out of bound? I want us we go and research more on this. So.
Yes, I think we have the answer.
Uh-huh.
In that list, within a list, we have we have x is equals to 1, y is equals to safety. So there's I don't think we have like a third is it variable, something like maybe x, y, z. We should have maybe, oh, z is outside. Let's use maybe a is equals to something else. Then it would have displayed maybe that. But now it's between 1 and 2. Then the second one now. I think if that is the answer, that is. For the third, there's no third.
We don't have a land storage serial. That's the confusion
Yeah.
I was getting. That was
There's no third storage. So
yeah, because actually what we have here is we have list as 1 serial. We have the first list as 1 and we have the second value as b. Serial. Yes, that is there. That is where we are getting out of bound error. So we the R does not count at the x's as 1 entry, these as second entry, the other one as third entry. So it combines this as a list of 1, this as a list of 1 here, then we have the second one there. So that is it. Which is the other? The third method of subsetting now was subsetting using this operator, the $sign operator. So the $sign operator can be used for lists and data frames in our unlike the closed bracket operator. It will select only a single observation at a time. It can be used to associate an element in named list or a column in data frame. And operator is only applicable for a recursive object or list-like object. For example, when we have a list here of one entry, we have a list of A, B, C, and D. We can pop out these entries. We can display the entries, for example. We can have those entries there. Then we can select A. What is in A? Direct here. So what is inside A? Because we have A's has these values. We have A is 1, we have B as 2, we have C as hello 1, and we have D as GFG. Now, when we run this command, it means that we are selecting the values of A directly from is, but we use the dollar sign. That is the other method of selecting using of subsetting data using dollar sign method. So I think that is very simple. Sido, is it making sense? You can you can
Yes,
even
it is.
yes, you can even select another letter, for example D. Let's see what will happen. Sido, you can. This is very simple. So that's a straightforward idea.
Question. Question. Can I
Yes.
reach in the previous scenario we had a list
Yes.
inside a list. Can the
Pardon?
same be used? We have a list inside a list instead of another list like the previous example. Can the same be used?
Sikupati unaongea ukikatakata sauti.
Kwa nauliza
Uh-huh.
For you, the previous example,
Uh-huh.
we had a list inside of a list.
Uh-huh.
can the dollar sign be used for the same?
Let's see. I think we can write a command on the same. Huh? Where is the list? The list is on which number? List
Mine is
inside a list.
60.
Iko kwa entry number ngapi?
In mine it's 60 because I've also been touching, so it's around 60 there about.
Oh yes, we have it here. So this is a list inside a list. Sindio? Let's try to execute the same here. So I can print. What are we printing? We are printing Z. Sindio? Z. And then we use the dollar sign. Sindio? We use the dollar sign. I think when you display the dollar sign, you will just be able to display the entries of the list, the main list, not sub list inside a list. Is it making sense? Unapata? Because
Yes.
ukiandika dollar sign after Z, the compiler will display the sub entries of that Z. So A and B is the only value that can be returned using that particular sign. So we cannot return.
Wait, we can.
Huh?
I was trying something here. We can put another dollar sign after A.
After A.
Put another dollar sign.
Yes. Uh-huh.
Then put
Yes,
I
yes.
put Y on my end. I put Y.
Yeah, actually, yeah, it's working.
Yes, a dollar sign instead of, so it's a dollar sign instead of a dollar. So the dollar sign overcomes the what do you call what these marks are called what? Brackets.
Yes. So,
Right?
but not a single dollar sign. See there?
Not a single. I think so.
Yeah.
Not very sure. I was trying something. So
Yeah,
for me,
so-
I just wrote print Z. Yeah, it's okay.
Yeah. So it's not a single. So you can connect all those type of dollar signs there. Ladies, mko wapi? What are you doing? So the other part was on where are we? The second example, Sindio. The second example we were doing cars, empty cars, Sindio. So we were doing empty cars, and as I said yesterday, empty cars is an index data set that comes with so So when you install R Studio, you will automatically have this data set. So this data set is just for practicing, for learning purposes. So we had this type of data set here. Is data sets comprised of different cars, and we have the attributes of each car. We have the MPG, we have the number of cylinders, displacement, HP, and tracks, all those entries. Now suppose you want to return the entry on displacement alone, on HP alone, on track alone, you can do it using the $sign. So you can do it using the $sign. For example, when you execute this command here, and okay, we don't have the variant, so we use the $sign, then you can display anything, any attribute that you want to display. So I think this is very straightforward. So yes. So the other one is for subsetting. Remember, you can subset using this type of operator here. So we end the air quality, which is also inbuilt data set. Then you can subset using the subset function. So in our programming, this type of function here is used to create a subset of vectors. So matrices on data frames based on the conditions provided in the parameters. Are we together? Then from there you can so for our case here, we are trying to return everything that has temperature less than this part here, that has temperature less than 65. Then you can run the command and print that particular those particular entries. You can subset more than once with more than one condition. For example, from empty cars, you can subset empties using gearbox, where we have the 5 gears and HP greater than 200. What are we going to return? We are going to return only gears and HP from that particular command. And this part here, the select part which has gears and HP, will be equated to MTC variable that we have created here under this function. So yes. So the syntax is very simple. When you select and you want to display some entries, we can use the C function to display only gears and HP. So that's what we want to be assigned to our MTC variable. When we execute the command, we can print and have them there. So yes. So what we did on our second day, that was on Tuesday. I want to touch something on what? On the loops. That is so let's continue. So we have done some division on those parts, and for today we can do revision on what we did on Tuesday on types of loops. Break for loop based on logical conditions. So we are coming up with looping with some conditions. So we can have break for loop based on a logical condition. For example, when you have a letter I which takes values from 1 to 10, we can display the squares of those values. Are we together? We can display the square of values from 1 to 10, and print those squares. But we can break our condition. We can break our condition for printing the values of squares if our value of square is greater than or equal to 20. Is greater than or equal to 20. Then we can break our process. But now remember the way I told you when we are going to display or to use this type of bracket here. This bracket here will open the main coding area. Then you can display another, or you can insert another command inside that particular programming part. So that is we display everything of every square of i's, that is from 1 to 10. We print the squares if these squares are greater than or equal to 20. Then what else do we want to do? We want our programming or our process to break out else if this condition is not met. So if that condition is not met, let's try to see what is happening here. What is happening? I want one of you to tell us why are we getting these values from 1 up to 100? Why are we getting values from 1 up to 100? Yes?
It is squaring all values from 1
From 1 to 10, see there? From 1 to 10. Are we together? Guys, tunapatana kweli? Kabila, are we on the same boat?
Yes.
Yes, we are on the same boat.
What is happening here? My values of squares are actually greater than 20 somewhere. See there? Now, my process will not break. Basing my argument on this part here. So because numbers from 1 to 10, they can display values that are greater than or equal to 20. See there? But what happens when we display values that are less than 20? What will happen? Or let's say, let's use
Only 1 to 16 will be displayed.
pardon, from 1 to
16.
let me see. Less than 20, see there? The values that are less than 20. Okay. I have a question before we proceed. What are we printing? We are printing squares of I. See there? We are printing squares of I. But our I takes values from 1 up to 10. Takes values from 1 up to 10.
Up to
Now,
10, yes.
should we be displaying values of I that is less than 20 or less than 10?
It should be let the values of I that are less than 10.
Values of I that are less than
1 to 10.
1 to 10. See there?
Yes, yes.
Yeah. Ideally, I was wondering why the statement was there as well. Because everything everything between 1 to 10
Mm-hmm.
is greater than is less than 20, that is.
Yes.
I think it's that sign that you have put there.
Uh-huh.
You have changed it from greater than. It was greater than in order that I think it breaks.
Yes, but our argument is on I's. I's is just a range between 1 and 10.
Yes, yet we are printing the square. So
Yes, we are
the break
printing the
itself should
square.
have been for the square.
Pardon?
What we are printing is the square at the end of at the end of it is the square
Yes.
of I.
Yeah.
The break ideally should be related to the square.
Yes, the break should be related to the square. See there? Let's see.
Change if square if a bracket instead of I, let's put square
Yes.
is greater or equals to 20, and then we see what comes.
Yeah. Yes, that is it. So. Are we getting? Are we ending somewhere? Yeah, we can change it to 2, for example. Yes, then greater the values that are greater than 2, squares of numbers that are greater than 2. We can have 50. I think for square is working, huh? Send it. The process is breaking for the values of squares. So which number should give us a square of 50? Which number should give us a square of 50? Mr. Benson.
7 times 7 is 49. I don't get why 64 is there.
Why are we getting 64 here?
Yeah, that's the question. I'm looking at it.
Okay, let's do more research on this one here.
I think it is fair because you are only querying if the square is greater than 50. So it has to have hit the first the first value that is greater than 50. And after 49, 8 by 8 is what will bring us 64. So the minute we hit 8, the system will break at that point.
Yeah, exactly.
That is it. So when we say greater than or equal to 50, I think we will get 7. Ama, you can
Yes,
try.
we should get 7.
We should get 7. So
No, same result.
the same
Oh.
result. So let's try 48. Try 48 from your side and run the command. So you're getting 49. So it's a square, but it's greater than.
It's because we are using the print command. Remember, we are first printing, then coming back to check in the loop the situation.
Yes. So Uganda, I just want to ask you a simple question. If you do 10 examples of loop, will you not be able to understand that the syntax for looping? You will you will understand that syntax. Whereas ladies in the market, Mary. Mary.
Yes.
You can tell us what you have said. For on loop. Let's continue. Naona wengine wako na mchezo, they are just dancing somewhere, but let's continue. I think Mr. Benson, ukifanya more examples of this type of loop, you will understand the language better, sindio?
Yes.
Yeah.
I wish I did this in campus.
Okay, very good. So the next one was on they continue to the next reason for loop, skipping some values, end of for loop. So what are we doing here? This is a loop of values of I that is in range of 1 to 10, and if i's are in this part here. Okay, what is the use of this part here? Before we continue, you must understand it. What does this mean? Hii inamaanisha aje? This is for skipping some values. This is for skipping some values. I want you to check on the use of dollar. Not dollar, the percentage sign. The percentage sign. So the percentage sign in R. What is the use of it? What is the use of that particular command before we continue? I want to hear from you guys. So this command here will display or will take the values of i's but skipping these two or any value that is inside here. Now when the values of i's are being printed, the compiler will skip 5 and 7, which is in this range, which is in this particular range. Then from there we have a condition here. It will break. It will break if we skip these ones here. Then we have the code block here. This is uh, times 6 of the squares of I. Then we print times 6. So yes. What don't you understand with this particular? What are you not understanding here with this particular code? And we can add another one here. For example, 2. What do you think? If we add 2, oh, this is for alteration. For alterating.
Where is the x6 coming in?
X6 is just a variable. So you can call it even y. For example, you can call it y, and here you call it y.
Okay.
Yeah. Remember, this is just an assignment operator. We have assigned the squares of I to this particular value called what? Yeah. So now we are getting the same. So. But now, what are we lacking? We are lacking alterations for number 5 and 7. 5 and 7. So now 5 and 7. 5 and 7. When we lack that type of alteration, we are remained with values 1. When you, what is, by the way, what is iterations? How do you understand by the name iterations? Iteration is just a repetition of what? A repetition of a process. So when we start from 1, we go to number, for example, 2, 3, 4, 5, 6, 7. We form like a pattern from 5, 7. So yeah. Then the other example that we did was on creating the fruit. Create fruit vectors. We end a vector called fruit. From that fruit, we can assign a statement.
Question.
Yes.
For the example you've just done, uh, the iteration is, you said it's repeating, yeah? So instead of like maybe 1 to 10,
Yes.
the range 1 to 10, if it were random numbers but they were repeated, maybe 1, 2, 2, 3, 4, 5, so on and so forth. At the 2, 2, it would have skipped 1, 2 and continued with the calculations, right?
Yeah.
Thank you.
So the other one here was for creating a fruit vector. We can have this type of vector here called fruit. It has these values. Then you can create.
Still on that first that question, that is, we are iterating.
Yes.
So where the system is supposed to get us squares, isn't it?
Yes.
But where is the square for 6? Where is the square for 8, 9?
The square
is there a limit somewhere
because you've been given for values of I in 1 to 10.
Values of I in 1 to 10. Hebu rudia swali yako tena. I've not understood it well. I'm waiting to hear from you.
Sorry.
Yes.
Yeah. Iterating for values of 1 to 10.
Mm-hmm.
And then see the square of, sorry, not 5, but we should see the square of 6.
Mm-hmm.
The square of 8.
The square of 3.
9.
Uh-huh.
3 we have because we can see 9 there.
So what are we lacking?
But we are lacking 6, the square of 6,
the square of 6.
Which should be 36.
Uh-huh.
We are also lacking the square of 8, which should be 64.
Uh-huh.
Square of 9, which should be 81.
And square of 10.
And the square of 10.
Which is, so we are lacking 4 numbers.
Yes.
But how many numbers do we have in our display?
We have 4.
We have
which one is for the square of 1,
we have
4 is for the square of 2, then 9 is for 3, and 16 is for 4.
The 16 is for 4. Now, what our code is doing here is doing a for loop, so a for loop, but when skipping some values, it skips some values randomly, but it must skip 5 and 7. Do you get the answer? It must skip 5 and 7 in our pattern. That's the reason why when you remain with only one number, for example, we have another 4. We have I think there's something wrong with this count here.
I think the assignment of 1 of y seems to be outside. Shouldn't it not be inside?
No. Inside here. Let me check.
Before the if statement or what?
Before the if state here. I think we will create more problems here. Y which is equal to I.
Not after, but before.
Before if.
Yeah.
Hapana, syntax itakuwa tumeharibu the syntax for if. For if. So we will have altered the syntax for if. For
I
if
can
again.
answer why we don't have the square of 8, 9, and 10. It's because of the break after 7, because there was 7 there, so because of the break. But between 5 and 7, there is 6. So that's the question maybe I would ask as well. Why don't we have 36 down here? Does it mean that when you put 5 and 7, so any number between 5 and 7, as you had explained, will be skipped?
So our process will break after 7, see now. Our process
Yes, but
will
between
break
5 and 7?
Our process will break after 7.
Why don't we first break at 9 and 10?
Uh-huh.
Then we see what it gives us.
We break at
so that
9.
we are able to determine, 9 and 10. And then we are able to determine what
Let's try to break at 9.
What
we
the
can
logic
try to break at 9 and see what happens here.
Up.
Then you are getting the same answer. So
No, you remove 5. You remove 5, and then you are left with 9 and 10.
9 and 10.
Yes. So instead of 5 and 7, put 9 and 9, 10.
9, 10.
Yeah,
So
what's the
we have
system?
squares of numbers from 1 up to what?
Yeah, so that we see what
Up
is
to 8.
disturbing the system.
Yes, we have squares of numbers from 1 up to 8. See now. Yes. We have the squares of from I is equals to 1 up to 8. See there. And what happens when you break at 9 alone? When your process breaks at 9? When your process breaks at 6? I think it's making sense, huh? Sit down. Is it? Are you getting I think we can use one number. Sit down. Benson, what do you think? We can use one number. We can use one number as condition for breaking.
Yes, exactly.
Yeah. It has a lot of sense when we use one number for breaking purposes. So it is making sense. Yeah. So it's breaking. From there, we can come on should we do these polynomials here? Ni gani ingine mnaona ni of more importance hapa yenye tulikuwa tumefanya so that we can repeat on it, then we can call it a day. Ama ni gani yenye hamuelewi for the remaining part? You can scroll down. Ama uko na question now from kutoka kwa time tulianzia. Then I give you your project on what you are supposed to do. Do you have any question? Okay. Let me see whether we are supposed to do the data frames today. We touch on it before we end the lesson. No, data frames is not for today. Do you have any other question? Benson, do you have any other question? Ladies,
No.
Ladies, where are you? Where's Mary? Mary, I request to hear your voice in this class. You are so quiet.
Sir, you've like called me like I don't know how many times.
See,
Okay. I'm learning. I'm still learning, and I think for now I don't have a question. Yes,
okay. Do you have any
but
question? Do you have any question?
I don't have a question today.
Okay, Mr. Patrick, do you have any question?
No.
Okay. Mr. Mbonte, you can say 1, 2, 3 before we do the project, before you give the project. So for the cons, please make use of them. Revise using them. So. Revise more using the cons. So. And by the way, hebu niwaambie tukiachana leo ukatae kufanya revision na kujisharpen more on this language, utasahau sawa, utasahau. So it's a good advice, huh? You just when you're for example when you're mnafanya online writings, the academic writings, itisha task zenye zinafanya na R, you do with R. We have so many tutorials in YouTube. You can follow them to do MBCD, then everything will be okay. Mr. Bonte, do you have anything to share with us before we end?
Not really, but just on class attendance, I think some of us are doing poorly. I think on Monday the class attendance was high, but on Tuesday and then Tuesday after Thursday, Wednesday, it has been quite low. So please be attending the class. You've another 2 weeks to go for you to maybe complete the R language. So attend the classes and do more revision, and then that is all I think I have to say. And encourage those who are not attending on regular basis to be attending.
Yeah, that is it. Ukikataa kuattend, surely where will you get this knowledge from? Hautapata, si ndio? But I'm sure today for what we have done, you have grabbed ABCD from what you have done, si ndio? So let me give you the project on what you are supposed to do. Do more research, and for the project you will be submitting in form of cones, and one full cone, not 2 or 3, the way you are doing in SQL. So you write everything in one command, script, then the R script, then you will upload it.
Excuse me, sir.
Yes, John?
Okay, how do you save the script?
Okay.
Yeah.
I want you open you open here, so and click Control N, so Control. Let me see. You can click on File and New File, then R script. See there. Control Shift N. Yes. You can click on Files, New File, R script. Itakupeleka hapa for the R script. Are we together?
Yes.
Then you write your code, then you save. You just Control S. So.
Yes.
Okay, Control S, I expect you to write your name here. For example, John Jenga. So.
Yes.
Then you save.
Okay, thank you. Yes,
so
thank you.
Kwa your file directory, hiyo ndio utanitumia. So. That is it. So I think let me share with you the code, the project, then everything will be okay. So okay, let me share with you. I think you can live at your own pleasure. We have some 10 minutes. I use it to send you the assignment. Then you do ABCD and everything will be okay. So acha niwatumie the program. You can live at your own pleasure. Na mwambie wenye wakuje darasa wakuje because within complete marks you know how strict things will be. Sawa sawa, usipate soup, usipate supplementary.